Okay, so this week, what we're actually going to do between today and tomorrow, we are going to talk about how to interpret the data. We're also going to how to show it in different visual representations like graphs, okay? So today we're going to talk about box and whisker plots. In all honesty, guys, when I started teaching 6th grade, I had to go learn what this was. I had no clue. They make a lot of sense, and they do visually represent whatever data you're finding, okay? So the last 2 weeks we've spent time finding mean, median, mode, range, all of your quartiles, MAD, all that good stuff. So we've done all like the computation. So now we're going to take that and we're going to turn it into different types of graphs and how to read those graphs. So for a box and whisker plot, the 5 values that we're going to be using are the median, the upper quartile or your UQ, the lower quartile, and then we're going to need our lowest value, which is just your lowest number, and then your highest value. So those are the 5 numbers we're going to be using to make a box and whisker plot. A lot of times you'll hear like they'll refer to the lowest extreme or the highest extreme. That just means your highest and lowest numbers. So, as we've said the whole time, what do you think? If we have to find all of these values, what do you think the first thing you have to do is? Sort them in order, least to greatest. Because if you don't, you can't figure out these values. Now, the other way that I want you to be able to recognize data, this is called a line plot. The other name for it is also called a frequency table. What does the word frequency mean?
Like how often?
How often? Absolutely. So, like the example I gave earlier today was dentists say the frequency of brushing your teeth every day should be at least 2 to 3 times a day. It's how often you do that per day. This is talking about how often these numbers show up in our list of data. So looking at this, how often do you think 65 shows up? 0 times. Okay, but then we look at 58 and it shows up twice. So the great thing is they're already in order. We just have to go through and list our data according to how many times it shows up. So we would have 58 twice. And then we have 60. And then 61 twice. And then 63. Oh.
Aren't you going to record?
I am.
Oh.
Yeah. You're good. And then, let's see, we have 67 twice.
You forgot 59.
But look, there's no X above it. That means it doesn't, because it's not in my data. If I haven't recorded it in my data, then it will not have.
That's just each number.
Yep.
It doesn't really mean anything.
So looking at this, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, looking at a frequency table, usually it's pretty easy to pick out your mode. What would your mode be?
58, 61, and 67.
Yes. So you have 3 modes on this one, and those are the ones listed most often. All right. So again, the 5 values we're looking for. First is the median. What would our median be?
63.
Yep. Okay. And what about our upper quartile?
68.
68. What about lower?
60.
Okay. So those are the 3 values, and then your highest value and lowest value.
58, 72.
So this is what we're using to create our box and whisker plot. Your box is going to represent 50% of your data. It's going to represent the large middle chunk of your data. And we're going to do that by using our lower quartile, median, and upper quartile. So we're going to put a dot above, not on, but above 60, 63, and 68. No, above the number line. Yeah, this number line. So then we're going to box those in. And then we're going to draw a line through our median. So the distance from here to here represents what? Do you remember? You got it. The distance between your lower and upper quartiles, inner quartile range. So this whole box represents your interquartile range as well as your median. So we've done the box part of box and whisker. Our whiskers will go to our highest and lowest values. So we put a dot on our highest value, which is 72, and we draw a line. And we put a dot on our lowest value, which is 58, and draw a line. Now, at this point, you have separated your data into 4 sections. What do we call those? Quartiles, okay? A lot of times you'll hear your lower quartile referred to as Q1, and that's because it's the end of the first quartile. Your median can also be referred to as Q2, which is the end of your second quartile. So what do you think your upper quartile is? Q3, which is the end of your third quartile. The thing is, each of these sections will represent, and you don't have to put this on every box and whisker, I'm just putting it on your notes so that you can remember it. Each of these sections represents 25% of your data. It means that 25% of your numbers fall in this section, 25% fall here, here, and here. So, if we were asking what percent of the data is between 60 and 68, it would be 50%. Right here. Between 60 and 68, that's 2 chunks, 2 sections. Each section's worth 25%, so the data represented between 60 and 68 is 50%. Because these are quartiles. They're divided by 4, so when you take 100% of your data and divide it by 4, each section's worth 25% of your data. All right, half of the data is higher than what number? 63. Again, median is the middle, so half of it is higher than 63. Did you have a question?
Is it always going to be 25%?
Yep. Anytime it asks a question about percentages, you have 4 options. It's going to be 25, 50, 75, or 100. Because each quartile represents 25%. Because the whole thing is 100. So if we're splitting it into 4 equal sections, then each section is worth 25%. That's why they're called quartiles. Quarters. Okay? All right, let's try another one. Okay, again, let's see our numbers least to greatest. We have 60, and then we skip all the way to 66. But we have 2 of those. 2 68s and 3 74s. 176, 3 82s, and 2 86s. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're going to split our median. 1, 2, 3, 4, 5, 6, 7. Okay, what falls between 74 and 74?
74.
You got it. So what's our upper quartile now? It's the second. It's the second 82 because we got 3 on each side. And then what about lower quartile? Okay, it's the first 68. So again, we go through. We're going to make our box first. So we have 68, 74, and 82. We box that in. Yes, that's why it's called a box and whisker plot. What's my highest value?
86.
Okay, so that's going to be a whisker. And my lowest?
60.
Okay. Now, whiskers are not always even. If I had a symmetrical data set, meaning it was the spread was very symmetrical in shape, then my box and whisker would be very symmetrical. What if I had a much longer whisker over here? What might we say about this number out here?
It's an outlier.
It's an outlier. If you have an extremely long whisker on your box and whisker plot, it usually means that you might be looking at an outlier because it doesn't really fit with the rest of your data. If you were looking for a consistent data set, do you think your box and whisker would be really large and spread out or tight and close together?
Tight, close together.
Absolutely. Because remember, consistency means that you're looking at the same thing being able to happen over and over. So let's say you're shooting free throws in a few minutes. Okay, like you've got 3 minutes to shoot free throws. How many can you shoot in 3 minutes? What do you think?
21.
All right, there we go. So 3 minutes is a long time. But let's say one person does 0. Everybody else does like 20, 21, and then, yeah, around that, okay? So that 0, that's going to be a really long whisker, right? Okay? The example on the video, and I will send the link to the video you can watch later, they were talking about a basketball coach trying to decide which player he wanted to put in. So you had one box and whisker plot that looked about like this, okay? And the other, comparing them right on top of each other, would have been situated right about here. Which player would you put in the game?
The bottom.
The one on the top. They have a smaller range, meaning they're more consistent, okay? And if they're situated right about here where you're comparing, that means their lowest value is about where this one's upper quartile is. Okay? So the farther on the number line, I'll try to pull up a picture in a minute so I can show you. But the higher on the number line that this majority of your data sits, the better off it is. Okay? Depending on what you're talking about. But for basketball, we're talking about points per game, it would be better. Yeah.
What's the difference between the long and the short?
Between the what?
Long and the short?
This one has a very wide range.
Down.
Mm-hmm. So think about this. If I have, let's just say these are test grades, okay? Do I want this big of a range? 26 points?
You don't want someone to be making that low of a grade.
Right. So wouldn't it be better if my range were somewhere right about here? That means my lowest grade's here. So what you're looking for in some situations is you want a shorter box and whisker because that means your data is more consistent. Okay? Let's look at some questions on this. What is the range of this one? 26. And then what percent is between 68 and 86? 75 this time. And look why. Look. Here's 68. Here's 86. How many sections do you have? 1, 2, 3.
I didn't look at that.
So it would be 75% between the two.
How did you get 71?
Remember, each of these sections is worth 25%. So if I'm starting here and going up to the top, 25, 50, 75.
Why would they all be worth 25% if one was like way longer than the other?
Because it's not values, it's number of data pieces. So right here we have, how many did we have? 14? Okay, so that means in this section, what's 14 divided by 4? Like 3, not quite 4. Okay, so look, how many are in this section? 3. How many are in this section? 3. How many are in this section? And there, 3. So it's dividing the numbers into 4 sections. Grab on that. Yeah. All right, so what I want us to do, and I'm going to keep videoing since we've got a lot of people out today, we're going to go ahead and start looking at homework together. Do you see it back there? Oh, never mind, I brought it with me. Sorry. I was trying to be prepared. So we're going to go ahead and start looking at some of your homework together, okay? Hopefully this will help you guys. You won't have so much to do tonight.
What is the, how many problems?
There's only 3. But you're creating a box and whisker, and then you've got to do some evaluating of it. Good. You're welcome.
What if we do we have to draw the number line?
Yes, you will on this one, and I'll show
Can
you.
we draw the number line and just fill it out on the top instead of having to write the
No,
numbers
we're going to
out?
write them. All right. Any questions so far? We good so far?
Yes,
Everybody?
I have a question.
Yes.
Why is math so fun?
Yay. Yes, question.
What is that? Why are you looking at me like that? I know how to do it.
It's a visual representation. It's a graph. Well, it's still recording. So you can visually compare. I'll try to pull up in a minute some examples to show you. This is used quite a bit in business fields to compare like weekly progress, where they can look at all four and just visually compare without having to compare the actual numbers. Okay guys, back to me. Let's remember, we are still recording. Okay, so looking at the first one, what is my first step?
Put them in order.
Put them in order. So we've got 1,
And 2, 3.
we have 3 2s, 2 4s, 1 7, 2 8s, and 1 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 10 numbers. So what is my median?
4.
Yes. Now, let me say this real quick, because I was kind of lenient on your test on Friday, which I will get those back to you in a minute. If you have a median that is between 4 and 4, it is not 4.5. It is not 4.5. It is 4. Because, guys, the rule is if you fall between two numbers, you add them together and divide by 2. Well, 4 plus 4 is 8. 8 divided by 2 is 4. And there's nothing that comes in between 4 and 4. So your median would be 4. Okay? What about my upper quartile?
8.
Okay. What about lower?
2.
All right. So now, we're going to draw a number line. The only numbers you need are what are on your list of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And yes, I want you showing everything I'm doing. You're not having to show a ton of work, but everything I'm doing I want to see on your paper, okay? Okay, so what 3 dots are we going to mark first? Yep, 2, 4, and 8. 2, 4, and 8. That creates our box. That is our inner quartile range. What's my highest value?
8.
9. And my lowest value? 1. Now, see how short those whiskers are?
Those are short.
They are. It is possible to have a box and whisker that only has 1 whisker or no whiskers. What it means is that you would have, let's say this is an 8 as well. We had 8 3 times. Then our highest value is also my upper quartile. So if this were 8, I would not have a whisker, and that's okay. If this were also a 2, that would be my lowest value, and I wouldn't have a whisker. So it's possible to have 0, 1, or 2 whiskers on a box and whisker. What's your median? 4. And what percent is less than 2?
25.
Right here, 1 section, so that's 25%. Remember, I told you if it's a percent question on a box and whisker, you have 4 answer choices, 25, 50, 75, or 100. Now, I'm going to go ahead and forewarn you to fill in all these numbers. You got to back it up all the way. Okay, so we've got 111. We've got 2 13s. 3 14s. 2 15s.
Why are there so many numbers? What's the point of giving us that?
Practice.
Just show us that you can put a lot of numbers on a sheet.
Practice. A little bit of challenge.
I can do that too, you know.
So you should have a total of 20 numbers. Okay. Looking at this line plot, what is your mode? 16.
No, 16. I sure wouldn't be 19, 14, 13. Oh, because you see it in the mode.
16, you have 4 times.
Would we have to put 18.5 on a number line at the bottom?
No, I'll show you in just a second. All right, so let's look at this. We're going to create our number line. We need to go 11 to 20. All right, what is our median?
Your median's 16.
Because it falls between 16 and 16. Okay, what about my upper quartile?
8. No, 19.
It's actually between 18 and 19,
18.5.
so it would be 18.5.
So, and did I get it right?
You would add those two together, divide by 2. And then what about my lower quartile?
14.
Okay, it's between 14 and 14. Wait, 1, 2, 3, 4. It's actually right here. So we're going to mark those first. 14, 16, and 18.5 is going to be between 18 and 19. So no, you don't have to actually write it on your number line. Just put it in between 18 and 19. What's my highest value? 20. And my lowest value? 11. Now, what percent would you see between 14 and 18.5?
75.
Look again.
50.
14 and 18.5. It's going to be 50%. Because there's 2 sections. Okay, and then what is your range? 9, because it's 20 minus 11. Okay. All right. We good so far? Okay. All right, let's talk about interpreting. They have drawn the box and whisker for us. We actually have 2 we're comparing, and this is what I was telling you earlier. These are 2 companies, and they're video games sold per week. Okay? So when we look at the range of each company, what would company A's range be? Let's see, it goes from 31 to 23, so 8. What about B? 11. So B has a wider range. What we talked about just a minute ago, which one do you think is more consistent? A. The range is smaller, it's more compact. All right, what about the median?
It's 28.
20 and 28.
So the median for A is 28 and B is 20. So that means the middle value on their sales, again, we got a big difference there too. Now, which company appears to be more predictable? Company A.
Because their sales are less spread out.
Absolutely. Their sales are more compact. The other thing I want you to notice, look where their lowest value is and look what it lines up with,
23.
which is the upper quartile for company B. So which one do you think not only is more predictable, but is consistently making more money?
Company A.
Company A, because look, their lowest value is almost one of the top values for company B. So this would be a great representation when you're trying to compare. I don't have a list of numbers for either of these. I don't know. I could go through and I could find the median. I could find my upper lower quartile. What else could I find? My interquartile range. I could find my range. I could not find the MAD. I can find the interquartile range. What can I not find? The MAD.
The distance.
The mean.
What about the outlier? Did you find 27?
There's no 27.
I could not find the mode because I don't know what numbers are listed, right?
Oh, yeah. Why can't you find your mean?
Huh?
Because you need all the numbers, so if there's like
I don't
3
know.
of one, there is all the numbers.
No, these aren't all of my numbers. I may have, hey guys, back to me for a second.
326 is.
I may have, since there's a very short whisker here, this may be 15, 15, 15, 16, or it may be 15, 16, 16, 17, or it could be 15, 16, 17. I don't know how many are listed in there.
Heck, you should have 1032s.
Absolutely. I don't know because it's not showing me how many numbers I have. So there's only a few things that we can't find from a box and whisker, but we can use it to evaluate the median, the quartile, all of your quartiles, your range, all that good stuff. Yeah.
Why is there no 27?
That's a great question. I don't know. Oh no.
They didn't like the number 27. Stop complaining.
All right, I'm gonna stop this here.